Andrei Rugina is going to present microservices approach in ING mobile banking. Thank you.
Hello, everyone. My name is Andrei Rugina. I work for ING as software architect for internet banking platform. And today we'll talk about the microservices approach, that is the way that is currently under implementation within ING. And what is this relationship with modularity? So microservice is a form of modularity, but it's not enough. In order to benefit from all the advantages a microservices approach can bring, we also need to apply structural modularity. So this is our main topic for today. But first, let's start with the history of internet banking within ING. Last year, it was voted the best internet banking solution and mobile banking solution. I'm saying this only to capture your attention and be sure that you have patience to wait until the lunch break. But we will focus on the technical evolution of internet banking. So the first version of HomeBank was launched in 2006. And it was based on a classical web framework, action-based framework called BTT from IBM. It was a specialized commercial web framework for banks. And it has a classical MVC structure. Now you have a main dispatcher that maintains a registry between commands and delegates to the right command. And the command pushes the data into a context, in usually session, but you can also have a hierarchical context. And the rendering of the page is delegated to a template engine that has access to the context. So this was the first version. In 2009, we started a migration project to a new architecture because we wanted to benefit from both features. We wanted to have a workflow engine to implement in a declarative manner the flows in our application, but we also want to offer a rich user experience to our users. So we also wanted to have a component-based and to have rich user interfaces. So this was an architecture based on Spring Webflow as a workflow engine and GSV as a component toolkit, component framework. In 2012, we adapted the application to mobile channel. And we implemented a hybrid approach. So we developed in-house a native wrapper that hosts the web application. And we had different flows for mobile and desktop. But we aim towards a greater usability. So in 2014, we started to implement, to rewrite from scratch almost our application. And now we have a single page application running in the same native wrapper, written in AngularJS. And on the server side, we have a set of REST services with the right granularity in order to support future channel application. So this is very important. The API design becomes very important because it is intended to be reused across channel application. In November last year, we also launched a subsystem of HomeBank, which is in charge mostly with offer management and in the future with mobile payments. And this is where the microservices architecture starts. And all the new functionality are developed as microservices. And in time, we plan to migrate the current code base to a microservices approach. So let's talk about microservices. We'll talk about the external structure, how the components are created, what are the rules that govern the communication between them, and we also talk about the internal structure of microservices. So the idea is to decompose our application into loosely coupled services, and let these services to communicate over events, because the more services you have, the more communication cost will incur. So you need to be able to offer resilience maintaining in the same time the flexibility of the application. Letting the services communicate asynchronously synchronously is not a solution, because it increases the complexity, and also it doesn't offer a very stable architecture. We want to limit the scope of our transactions. So this is our first objective in order to offer a resilient architecture. We want to be able to limit the propagation of the error. So I think these are the main benefits. Now we can have multiple, and we have parallel multiple development teams that can work in parallel. And we also have a resilient architecture. We want to be able to stop the error from propagating to other services. So we want our services to be decoupled as much as possible from other services in terms of availability, first of all. We want services, microservices, to be temporarily decoupled. So these are the two principles that governs our design. We intend to have the services to be autonomous, to be as much as decoupled from each other, so they can be deployed and scaled independently. And we also want them to have an explicit contract. And part of the contract is not also the API. It also the format of events. So events are part also of the contract exposed by modules. And yeah, I'd like to mention also that the services, the REST or SOAP endpoints, normally are called either directly by the native application or by the single page application, or they can be called via an API management solution. For example, if you want to aggregate the results returned from several services in order to reduce the network round trips and offer better performance, or can be called via an SB. So the top layer in our architecture is represented by the ESB or by the mobile application itself. But below this is a microservices architecture. And one of the most important building blocks in our architecture is the event bus. Because the events should be conceived, should be thought of as a domain events. They should capture the state changes in the domain. One important rule for obtaining these loosely coupled services are offered by the domain event design. Because one of the consequences of letting modules communicate over events is a type of consistency we cannot achieve. So in order to have strong consistency, in order to preserve the business variant, which will limit the transactional consistency within a module boundary. So the use cases are very important, because from the use cases we can derive the consistency rule we want to enforce in our domain model. Another consequence is the eventual consistency between modules. Eventually, consistency is a broader term and can mean many things. Usually, it depends on the use case as well. So, for example, if you have just a pure analytical modules, the order of events that doesn't matter so much. So, a pure eventually consistency requirement is good enough. But most usually, you need a stronger form of eventually consistency. You need, for example, a consistent prefix and monotonic reads. So you want to be able, in the subscriber modules, in a microservice architecture, to have access to a state that was derived from a consistent state of the publisher module. You want to be able, in order to achieve this, you need a messaging solution that preserves the message ordering. Message ordering doesn't need to be a total event ordering. It can be a partially ordered messages. But again, what can help us in this regard is again the domain-driven design principle. Because normally when you design your domain model, you should decompose it into aggregates. And aggregates are the unit of consistency within a domain model. So these are the boundary inside of which you should be able to preserve the business invariants. So what you actually need is to, and every aggregate is responsible for publishing the domain events. It's responsible for capturing the state changes in the domain model and publishing to the event bus. So what we need is just ordering over the events published by a single aggregate instance. On the other hand, we have a special subscriber to the event bus. And this is the event store. So event store is responsible for subscribing to all the events and maintaining a history of all the events. This is important in order to recreate the state of a subscriber module. We want to be able to replay the events. So also the event store is another important building block in our architecture. So to sum up the principles, we have modules that are exposed using REST or SOAP that communicates over events with other modules. And these modules, they are aligned with business capabilities. They are derived from the business understanding of your application domain space. We should aim to match the boundary of a module with a boundary of domain context. Domain context with a bounded context. A bounded context is based on the business knowledge you have, and is unity for which you have a separate domain model implementation. And as I said before, is also decomposed further into aggregates. So our rule is to have one microservice per bounded context. And modules, they represent the source of truth for our data. So a module, a bounded context, is the owner of data and the owner of business capability. So we should also limit the layer dependency. Not only the modules need to communicate over events, the module needs to have their own storage. They need all the access to a module is done via the API or via subscription to events. This is a very important principle for communicating between modules in a microservices architecture. And now we can talk about the internal structure of a module, of a microservice. Normally, we should follow the principle of hexagonal architecture. I mean, in the literature, you can find different names for the same kind of architecture, which is very similar with the layered architecture. But the main focus is that we should isolate your domain model and your application services from the technology you use for exposing to the outside. So you should think of persistence or the remoting technology you use, like the REST or REST framework or the web services runtime, as adapters. These are adapters to which you expose your business functionality to the outside world. So this is very important, to have the right dependency in place. It's very important to let the domain model know the most abstract and the most useful in terms of reusability to be on top of your dependencies, or depending on your how you look, to let the other modules to depend on the domain model. So normally you'll have the domain model, and everything should depend on it. The persistence should depend on it. The messaging infrastructure you use for publishing the event should be also depend on it. The remoting technology, like the REST framework or the web services runtime, should depend on it. And you should also be careful how to wire all of this together, because you don't want also to depend on the concrete implementation. You want to let a dependency injection container to assemble all of this together. Because the principle is that we should not let the domain, the business logic, depend on the technological aspects. So frameworks are implementation details. This is our conclusion, to reuse the business logic in other contexts. And also the deployment option should be deferred under build time. The deployment option, and I will go into details in the next slides, should be build time details. And how we can achieve this kind of architecture? How can we invert the dependencies in the direction we want? Basically, we have a very important principle that we should apply it in a consistently manner. And this is dependency inversion principle. Normally, when you have a business class that depends on a framework-specific class, now, when you depend on a class that is directly depending on the framework-specific details, we should create an interface. And the interface should be described in the terms of the domain model. And we should offer an adapter implementation of that interface that delegates to the framework's specific class, to the class that contains a direct dependency with the implementation environment, with the implementation, with a specific framework. And it's very important how we package this. So we should package the domain model class and the client-driven interface within the same package. It is recommended to package within different modules, and we should also package the implementation, the adapter implementation, and the concrete and the framework-specific class in another package in another module. So this is a way we can achieve the right direction of dependency from the implementation, from the framework-specific classes to the domain, to our domain model. Because I want to emphasize again, we want to be able to reuse our domain, our business logic in different contexts. I mean, in the end, a microservices is first of all a logical construct, and is the owner of the data, and is the owner of the business capability it provides. And we should be able to reuse in different contexts this capability. We should be able to deploy this wherever we need it. So we need an architecture that should support many deployment options, because the deployments are actually a trade-off. Our architecture should be flexible enough to adapt to different deployment contexts. Deployment, as I said, is a trade-off between the non-functional requirements you have. For example, availability or fault tolerance, failure isolation, to what extent you want to achieve failure isolation. So this kind of non-functional requirements, and a trade-off between non-functional requirements and of course costs. So we'd like to support a very broad range of deployment options. So at one end of the spectrum, we have a very isolated architecture, where we have a microservice per web application, per application server, per virtual machine or Docker image. On the other end of the spectrum, you have a more easier to manage deployment scheme, where you have all your microservices deployed within the same application, on a single application server, on a single machine. Between these, there are many other deployment options that now offer different degrees of isolation between microservices. But our architecture should support both of them. So as long as we follow strictly the communication rules that I said, communication over events, using a publishing subscriber messaging infrastructure, we can achieve this kind of flexibility in deployment. But usually, there is level of granularity in architecture that usually is missed. And this is represented by bundles. So let's talk about the granularity layers in an architecture. You have, of course, you have classes and you have namespaces or packages, and you have microservices. But in between them, it's also very important layer of granularity, and is represented by bundles, or jars or DLL in the .NET world. Let's call it also modules. This architecture for microservices, the internal architecture for microservices, is misleading in some respects, because the actual picture is more similar with this. So it's not only the domain model and the adapter for the REST or for SOAP and the adapter for the persistence and messaging. No, you have all the other modules that your frameworks depend on and your adapters depend on. You have the dependency injection container. You have many modules within a microservices. And if we want also to support multiple deployment options, this complexity is multiplied, because you want to be able to deploy many microservices within the same web application context. So this means that all these modules proliferate, multiplicate. So the complexity actually, it's much bigger than this one. And we want to be able to offer this kind of flexibility, to support all this range of deployment options, to be able to reuse our microservices and deploy it in other contexts and deploy it wherever we want, wherever we need it. So what we actually need is a structured modularity. The structured modularity means that we need to apply the modularity principle at each level in our architecture. What I understand by structured modularity, I understand a few principles. So first of all, we need a hierarchical modular architecture. We need to think of our architecture in terms of granularity levels. And we should be able to express this dependency in terms of abstractions. So, and also we should be able to compose an element, a modularity unit at some layer, guaranteed layer in our architecture, in terms of the previous modularity units on the below layer. So we need a hierarchical modular architecture. We need isolation. We want to limit the way modules communicate between each other. We want to separate the API module, the public API of a module, from the implementation details. And we also want to express the dependency between different elements on some level of granularity in terms of abstractions. For example, usually when you program in an object-oriented language, it's recommended to depend on classes. When you express your dependency at bundle level layer of granularity, you should be able to express your dependency in terms of namespaces. And the same problem can be raised also microservices level. You also need a way of managing the resolution. You need a service discovery or the service registry server. And we also need versioning. We want to be able to evolve over time. So we want to support future evolution of our modules and microservices. So we need also versioning. So we need hierarchical modular architecture. We need isolation between modules. We need a dependency on abstractions, and we need versioning. So this is our roadmap for implementing modularity within ING. Currently, we are on the first level. We express our dependency on direct identity of our modules. in Java terms, this is the way you usually express dependency in Maven. So this is a Maven style of describing your dependencies. The problem is represented by the transitive dependency problem. It's very hard to reason within such a system because your chain of transitive dependency is very lengthy, is very large. A change in a modules can propagate in all the direction and can impact all the other modules. So we need you need a way to break this dependency. You need a way, and the way to break this dependency is to express them in terms of abstractions. So we need modules that separate, that enforce encapsulation. We need modules that separate the public API from the implementation details. So this is a second stage now on the way in our evolution to a more mature modularity solution. And we also need to enforce the dependency. We want to limit them. We want to apply modularity patterns in order to achieve a low coupling systems. This is as well very important to apply and to follow the dependency within your architecture. And of course, maybe the final stage on our modularity path is to have fully dynamic environment. We want to be able to restart and redeploy independently modules. So I think I limit myself within 20 minutes, maybe even earlier, to summarize my message. Usually when we talk about microservices, there is an intermediate level of granularity you usually miss. And this is represented by modules. And we should enforce the same principle, low coupling, high cohesion, separation of concern at each layer of granularity within our architecture. So for having a successfully microservices solution, we should be able also to manage the complexity at modules layer. So the layer between the microservices and the namespaces or classes. And to support the deployment option we talked earlier, we need to enforce the communication over events. We need to be able to decompose functionality of our application into business capabilities according to domain-driven design principle. And we need to identify the correct consistency boundaries within our application. We need transactional consistency for enforcing business invariants. And we need eventually consistency between modules. So this is my message for today. Thank you for your attention. And I'm ready to take your questions.
Hello, Adrian Turcu here.
Thank you.
So Andrei, there is any connection between microservices and MCV, kind of like modular control view patterns?
Could you please repeat?
There is any similarities between microservices and MCV, model controller view patterns?
Yeah, but MVC pattern, now it's implemented on client side. So normally in a traditional web application, you implement MVC on the server side. And I mean, as I said before, when I described the evolution of Homebank, usually there are two types of MVC implementation on server side. You have a push-based or action-based framework that execute commands and push all the results to some kind of context from which the data can be retrieved by a template engine and rendered the results to the browser. And you can also have a component-based framework where you have listeners. You have a page composed from components, hierarchical components, and you can register listener. And from listener, you can retrieve. This is why it's called also pool-based framework, because you can retrieve data from business components. But starting with a single-page application, all this MVC implementation is implemented on client side. All we need on server side is REST services. And yeah, usually on client side, for example, in Angular, what you have, it's an implementation of model view model, or also called presentation model.
Okay, so it's different.
Sorry?
It's different.
Yeah, it's different.
Okay.
It's different.
Thank you.
Hey. Hi. So, can you share more detail about how to isolate modules within a single service, microservice, and not expose internal common dependency of a different version between two modules or stuff like that? So, do you have a solution for that, or just a purpose and you don't have yet a solution?
There are solutions. I mean, there are different. For example, in Java you have OSGI. In OSGI, you can really benefit from all these features. You can have proper module encapsulation, and you can really enforce to depend only on abstraction and isolate your implementation details from the public API of a module. And you can also have dynamism. You can have microservices in the sense of the OSGI that allows you to restart independently modules within a microservice.
Thank you. And is it possible that making a smaller granularity, obviously you could multiply the number of microservices, and so for me it's not clear why it's needed the extra level of modules. Do you have a similar module in different microservices?
I mean, you could reuse. I mean, no, you could. No, there are two types of reusability. You can have in-process or inter-process reusability. Microservices is an inter-process reusability unit, but you also need common helper classes, or I mean, even more than this. All this, for example, the messaging abstraction you need to use in order to decouple your domain model from the event bus. You need to deploy this as a library within each modules. So also the persistence. Maybe you have the same kind of storage within different modules, and do you want to reuse the same persistence mechanism?
Perfect. What about Docker? We had issues with Docker, like UDP routing and networking issues and flakiness, and for production, everybody says it's okay, let's see how we can adapt to use it, not for databases, just for the stateless services. And do you have any production experience in Docker, and certain actions you did to make sure? Do you use like a use case like transit, like short-term tasks or long-running processes? How do you deal with failure?
I mean, so you have two questions. One regarding Docker, and the one regarding how we handle long-running processes in a microservice architecture. If I understood well.
Yes. Do you run Docker in? How do you control Docker instability?
I mean, I have to admit that we don't use Docker. We plan to investigate Docker-based solution, and I mentioned that in terms of isolation, Docker seems to have offer a very good solution, because very good trade-off between cost and isolation. And it's a good point to make because normally the unit of deployment is represented by a jar file, by a bundle within microservices. But is all this direction towards immutable infrastructure, the unit of deployment becomes a virtual machine or the Docker image. So it seems that maybe modularity is not so important, but it's not true. And I'm not saying this because I'm against Docker. Actually, this is a direction our industry is heading to. So having the immutable infrastructure is very good, and clearly the direction we are going. But we should also preserve the advantages of a proper modular solution. We should also be able to deploy our application in a different infrastructure environment where maybe we lack the automation tools, because having Docker and virtual machine and without automation, it's almost useless. It's increased actually the effort. So enable to support all of this, we need to also pay attention to the right modularity at the module layer.
Okay, and the last question. when you talk between two services, if you have messaging, it's complexifying your API, right? Because if you expect an answer back, then you have to go to the queue again. So.
Yeah, no, this is very important. I mean, we should be, we should be careful about what represents a command and what represents an event. So normally the modules should come, the objective is to limit the scope of a transaction. So we should limit all this kind of interaction between services. We should rely more and more on events. So if we need a reply from the other service, maybe our way of modeling the problem is not correct, because what actually we need is a command and not an event. But even if we need a command, in this case, we need to model the sending of request and receiving of response. So we need to create some kind of aggregate that represents a process manager, that maintains so we should implement the state machine. And the state machine is driven by the request we send and the response we receive. And we should maintain this state in a database. Because this is a very important aspect that I didn't mention. Our services should be stateless. No, they should be deployed. We should allow for horizontal duplication and all this principle of scalability. So they should be stateless. But in case of orchestrating different microservices, this is why it's very important to implement in the correct way the domain-driven design principle, because we want microservices to operate mainly only on its logical, on its own data store, and everything else to be published as events, and everyone interested in these events subscribe to them and perform also their own logic. If we want to maintain some kind of state between events, if we need some kind to perform some kind of reaction or some kind of action based on the response, this means that we have some kind of process manager, and this one needs to be modeled explicitly as a kind of aggregate with its own persistence and its own data store.
Like in a different level of granularity, another domain for that workflow. Okay, and the last question. Okay. They don't have a question.
Thank you. Hi.
Hi. I don't have my glasses, so a moment of hesitation is normal.
When you decompose your application in microservices, do you follow only the functional part, or you decompose your services also from technical perspective, like business functionality, it's a microservice, storage, it's another microservice?
No. This is a very good question. I forgot to clarify this aspect. This is a kind of in an architecture where you have data services and task services and process services. I don't think it's a very stable architecture. It's an old way of implementing service-oriented architecture. A module should be autonomous, so should not depend for accessing its data on another service. Because the consistency boundaries, consistency rules are driven by the use cases. From the use cases, we can extract the business invariance we want to enforce, and we want to be able to do this with the right data technology. We don't want to rely and make our microservices less stable because we have a external dependency that is just a technical one. It doesn't bring any business benefit. So the answer is no. The microservices should be regarded as a vertical slice, responsible for its persistent logic, and also for logic for exposing the web services to the outside world.
Okay, thank you. And another possible issue, how do you have a general overview of the data that you have, taking into account that you have a distinct data store for each microservice. Do you gather all the events from different microservices in order to create also an overall picture of what that user has done? Or
Yeah, this could be a solution. You can have a subscriber to all the events, and you can maintain a copy of the data you are interested in. So you can aggregate what you need.
okay.
So this is a solution. You also can apply the command query responsibility separation principle. So you can, if you want to offer an aggregate view of the data, you can have subscriber also maintain the data in a distributed cache or a low latency data store. If you need to move all this data to a data warehouse, you can also subscribe to the event bus and maintain the data in a data warehouse.
Okay, this is the last question because there's food.
Sure. Okay, cool. So I was wondering if you can talk a bit about how your infrastructure design in terms of if you deploy all your microservices as highly available, or if not, like which ones are highly available and which ones are not, and how you decide.
Yeah, it depends on the non-functional requirements. Depends on what degree of availability we want to achieve. So currently, we have all our microservices deployed within the same application, web application, and the same application is deployed on a cluster of JBoss application servers. But there is one module that we want to, for which we want to provide a greater availability, and this is a mobile payment solution, mobile payments module. And for this will be also deployed in a separate application, for which we will provide a higher availability. And this is why it's important to follow this principle, because we can modify the deployment only in the build script. So we just modify, in order to achieve this, we just modify the build script, and we create an application with just one module, connecting to the same event bus.
Okay, you can talk over lunch. By the way, there is food over there, but I have to warn you, there are really big queues. So thank you very much, Andrei.
Thank you.